Tell us a little bit more about what the team in Micronoma is up to and the story.
Yeah, absolutely. So we are up to what many people are trying to solve. It's saving life. You go in science because you want to save life. And so one of the big killer we all know is cancer. A lot of cancer, unfortunately, are very deadly, but they wouldn't be that deadly if we can find them in the very early stage. So the team decided to find a specific biomarkers that would help detect cancer in the early stage. Other people have done that in the past, but they are very human-centric. Surprise, surprise, human are human-centric. So when we get at it on the biology side, well, we tend to look at the human genes or the cancer genes that are in the human. Myself and my two co-founders, we come from the domain of microbiome. So microbiome is a study of community of microbes, not just microbes in isolation, not one bad bacteria or one bad viruses, but really how these bacteria interact with each other. And that interaction and that community that's created is something we studied in the past within the environment, within our food, within our gut. Around 2017, 2018, the team decided to look at it on the cancer side. And we started by looking at something that was a little bit controversial in the broad audience, which is, well, let's look at microbiome in tissues, in our organs. Most of the thinking was just, no, there is no microbes in your organs unless you have an infection. Well, that dogma was wrong. There is microbes in our organs, and it was starting to emerge. And even when it comes to cancer, you probably have heard about HPV and associated with cervical cancer, or Helicobacter pylori associated with stomach cancer. So people were starting to think about it, but that was kind of the exception. And we brought to the forefront that no, it's not the exception. All of our organs have a microbiome population. We went deeper into that, meaning within an organ, we realized that the cancer tissue in the organ has a microbiome population, which is different from the healthy tissue in the same organs. Because we wanted to do early cancer detection, the natural next step was to go away from just looking at the tissue, because if you look at the tissue, you need to do a tissue biopsy. This is kind of late in the process of the diagnostic stage. So we started looking in the blood and thinking, much like other people before us had looked at liquid biopsy, looking for the genes, the human genes or the cancer genes that are coming from the cancer and are with the cellular turnover going into the blood, we decided that, well, maybe these microbes that we find in the tissue goes into the blood. And the answer was yes. And with a lot of machine learning and artificial intelligence, we are able to, based on the pattern of microbes we find circulating in the blood, we can figure out what kind of cancer they may be affected of.